Okay, so welcome back, and today we're going to start talking about a definition, well actually a couple of definitions, and this deals with looking at the absolute value of the terms of alternating series. So if we look at a couple of these, so I've got a couple of series here. This again is the alternating harmonic series. If we look at the series of the absolute value of the terms. So for example, if we consider the absolute value, so as n goes from 1 to infinity, the absolute value of -1 to the n plus 1 over n, right? Well, this just gives us the harmonic series. Right? And so we know this diverges. Okay? So when we have an alternating series like this, where we know the alternating harmonic series converges, but the series in absolute value diverges, we say that the series we say that the alternating series exhibits what we call conditional convergence. Okay, so whenever we have an alternating series where this alternating series converges, but the series of the absolute value of the terms diverges, we say that it has conditional convergence. Now, if we consider this one, and we look at the absolute value of the terms, that's just going to give us a P series, right, with P equal to 2, which converges. So in this case, we've got an alternating series. This also converges, where it converges as a series, but also the absolute value of the terms gives us a series that also converges. This is what we would say that these series have absolute convergence. Okay, or converges absolutely. Okay, and so we're going to introduce the next video, we're going to introduce the definition. We're going to formally define conditional convergence and absolute convergence, and then we're going to introduce the absolute convergence theorem, which tells us that if a series has absolute convergence, then it converges. Okay? And we'll talk more about that next time. See you then.